Okay, in this video we will cover some more examples from section 2.1. Now, in example 3, it says a bicyclist, my apologies. This section is still asking us whether the problem can be solved using pre-calculus or whether or not calculus is required. And same thing as before. If it can be solved using pre-calculus, solve it. If it requires calculus, use a graphical or numerical approach to estimate the answer. So, for example 3, it says a bicyclist is riding on a path modeled by a function, and this is the function, where x and f of x are measured in miles. See my figure. Then it says find the average rate of change of elevation at x equals 3. Now let's look at that problem compared to the next one. Example 4 is also a bicyclist riding on a path, but this time it's modeled by a function of this kind, where x and f of x are measured in miles, and they want you to find the average rate of change of elevation at x equals 2. They're very similar. The difference is this graph is a line. This graph is a curve. And if you recall when we were talking about what can be solved without calculus and what can be solved with calculus, the second item on that list was without calculus we could find the slope of a line. Remember, average rate of change is a fancy way of saying slope. Okay? And the slope can be found when it's a line. However, it's harder to find the slope at a point when you have a curve going on here. Okay, so on a line it's easy because the slope that's happening here is the same slope that's happening throughout the entire function. Whereas here, the slope of the graph at x equals 2 is not necessarily the same of the entire graph. Notice how if I were to look at the slope of 5, the slope of 5 is going in this direction. This is a positive slope going upward to the right. This is a negative slope going downward to the left. So this function has a different slope depending on where you are in the function. Therefore, this one will require calculus. However, here we know how to find the slope of a line. So the first part of our solution will be to say this can be solved using pre-calculus. And so then what we want to do is we want to find the slope. And it's very easy to find the slope because your function is f of x equals 0.06. My apologies, I forgot the x here. X. Now you remember this form, mx plus b. The slope is the number that's in front of x, the coefficient that's in front of x. And here, my coefficient in front of x is 0.06. So that is my slope. This is my average rate of change. Now, moving on to the second example, where it's not linear, and the slope here is not the same as the slope there. Therefore, I cannot just take whatever's in front of x. Not only that, but you have another variable here. There's no rule on which one of these is a slope, because that's not something you can do with a quadratic equation, yet. We will do that once we get into the calculus part of this course. But for now, what you can do is you can use your slope concept to figure out what's happening really close to 2. So what you can do is you can pick a number real close to 2 on the left, pick a number real close to 2 on the right, and find the slope between those 2 points. That is something that we can do. So if I choose, for instance, I choose 1.9 and 2.1. Those are very close to 2. Just a tenth of an increment to the left and a tenth of an increment to the right. Now, in order for me to find the slope between them, we have to use our slope formula between 2 points. We call this formula. So I know the x values here. What I want to do is find the corresponding y values. So I'll scribble that over here on the side. So when x equals 1.9, my function value is going to be this value. Now I don't know what that is, so I'm going to type that in my calculator. So clear that out. 0.04 parentheses 8 times 1.9 minus parentheses 1.9 squared, and close my parentheses. And I get 0.4636. So this is the y value that goes with it. Now, when x is equal to 2.1, we have f of 2.1, which means I need to plug (2.1) into my function. So I'm going to plug that in my calculator. Now I am going to use the functionality of the calculator. I'm going to hit second and answer. I think on the TI-84s you can just go up and highlight this and hit enter, and it will populate it here for you where you can edit it. For me, I have to hit second and then enter to get the last entry there in yellow. And so what I can do is I can backtrack, and instead of typing 1.9, I can type 2.1. Okay, it's helpful if you know how to use your calculator. I get this value, 0.4956. So now I'm going to plug everything into my calculator, or into my slope formula. So y2, the second y value here, 0.4956, minus y1, the first y value we found, over the second x value, which is 2.1, minus the first x value, which was 1.9. And I can calculate this in my calculator. Again, I may, for the future of these videos, use a different calculator, just because there's another calculator. I really enjoy the way you input things and then what it looks like when you're finished. This is a really old calculator, so it may not be as nice. And therefore I get this as my approximate slope.